to all and good afternoon to all. Okay, so chapter number 1, which is about quantitative data analysis. As we covered in the last lectures about the statistics, descriptive statistics, we covered in last lectures, and we taught about in last lecture about statistical, you know, descriptive stats. We covered descriptive stats. Now we can move for inferential stats. Okay, in this respect, okay, quantitative data analysis, hypothesis testing in simple words, hypothesis testing which we build or which we will build in our project. Hope you are also working on it. So these are the difference. We can go one by one. First, we just cover the error. Okay. Type 1 error, type 2 error, and the statistical power. Statistical power. These are the some of the errors. What these are errors? Okay, let's say in this type 1 error. In statistical hypothesis testing, a type 1 error is mistaken rejection of an actually true null hypothesis. I mean, actually your null hypothesis is accepted, but might be due to some calculation or in problem in robustic in your statistical techniques, you giving you a false result, but in actually that one is accepted. Okay, this is the type 1 error. How about the type 2 error? While type 2 error is the failure to reject a null hypothesis, that is actually false. It means we are accepting in type 2 error, basically we are accepting the hypothesis. In actually, that one is rejected. That one is rejected. Okay. Okay, and the last one is the statistical power of the binary hypothesis test is the probability that the test correctly rejects the null hypothesis while a specific alternative hypothesis is true. Very simple. This is also the same as type 1, type 2 error. Let's see here further more detail how we represent. Okay, can you give me a few minutes, please, to the lecture? Okay. Then, so further detail regarding type 1 error and type 2 error. See, type 1 error can represent with alpha. See this sign alpha. The probability of rejecting the null hypothesis when it is actually true. Yeah, same as the previous. A type 2b error can represent with the beta. This one beta. The probability of the failing to reject the null hypothesis given that alternative hypothesis is actually true. Okay. The statistical power 1 minus beta. The probability of correctly rejecting the null hypothesis. These all three can be happen. Okay, can be happen. This is for your information only. But our main objective is, see, this is the main objective. Choosing the appropriate statistical technique. This is also for your information. Okay, suppose. So there is a two basics analysis, univariate technique, basically two techniques, and the multivariate techniques. What is the univariate and the multivariate techniques? Let's cover here. Here, basically, there is a three types of analysis: univariate, bivariate, and the multivariate. Univariate, examination of distribution of cases on only one variable at the time. One variable. If you are going to investigate one variable, it's called univariate analysis. Okay. So bivariate analysis, the examination of two variables simultaneously, gather two variables. For example, relation between gender and the weight of the college students. How about the multivariate? Examination of more than two variables. Okay, simultaneously. Okay, see, relationship between gender, race, weight of college, etc. More than two variables. Many. Those analyses will relate with the multivariate analysis. You must get this information at first. Okay, this is clear. Understand? Hope you understand about the variable. What is the variable? We already covered. What is the variable, Joseph? like in your project, IV, DV, these are the variables, now variable which cannot fix. Okay, that is the variable. Variable can be even in your project, employee performance, one of the variables. Okay, acceptance of online learning, one of the variables. And even your other variables, I mean work from home, one of the variables. Weight variables, and there are many types of variables. You must know the basic definition of variable, by the way. Understand? Okay, now further information is related with this. Here, parametric and non-parametric. Parametric and non-parametric data. First, we covered the techniques. Now, we are going to cover the nature of data, type of data, parametric and non-parametric. What is the parametric? Oh, let's see here. Metric data, non-metric data. Here, maybe here, slide this here. I explained here. Data types. See here, metric, interval scale and ratio scale, where we must need a normality of normal distribution. Normal distribution means skewness. We already in last lecture we covered, right? Our data must be normalized. Normal distributions must be a normal distributions. Then we can say this is the parametric data. And for this data, we can use interval scale and the ratio scale. How about the non-parametric? Non-parametric mean abnormal data. We still can go binary, nominal scale and ordinal scale. Understand? Nominal scale and the ordinal scale. You must understand about the data types as well. For the parametric data, we must need normal distributions. Understand? For the non-parametric, no need. Okay. See here. Now we can understand these all phenomena. Univariate. Univariate mean, just now I taught you. Univariate mean, can anybody tell me, please? Univariate mean limb. What is the univariate? Are you around? Limb. Hope you are around. Yeah, you are around and you are taking breath as well. That means you are alive. Congratulations, you are alive. Can you explain the univariate? What is the univariate? Okay, Lim, can you respond me? Yes or no? Yeah, it means you are alive. Congratulations, right? Wow, wonderful, wonderful. How about Petrus, Gibson?
Yes, doctor.
Yeah, are you taking breath? You are taking breath? Taking breath.
Yes.
Breath. It
Yes.
means you are alive, right?
Yes,
you are alive.
Yes, I am.
Yeah, you are. So I can ask you a question then.
Okay, I will try to answer.
Okay, no problem. So univariate techniques. What is this univariate techniques?
Maybe only one technique that we use
No, one
to
variable. Investigation of one variable. Investigation of one variable is called univariate techniques. Investigation of two variables is called bivariate technique. Investigation of more than two variables is called multivariate techniques. Multivariate techniques. Okay. Please, my dear student, I need your attention. Okay. I need your attention. How about the parametric and non-parametric data? Son. Oh, are you alive? Live or alive? No problem. We are here only for the discussion. We are here only for the discussion. Don't be shy. Please, don't be shy. You don't know, no problem. We are here to discuss that concept. Sun, can you respond me? Sun Xiu Xiang.
Yes, doctor.
Yeah. So do you have any idea about parametric data and non-parametric data? No.
No.
No, wonderful answer. Good. No problem. See, so this is the data. See here. Please understand, data distributed into metric and the non-metric. I mean metric, for the metric we have to use interval and the ratio score. The main assumption for the metric data is normal distribution of the data, normal distribution of the data. Because in last lecture I taught you about the normal distribution of data, and the non-parametric, this data is not normal distribution. And for this data, which test we can use? Binary, normal scale, and the ordinal scale we can use. Okay, Paham, understand? Okay, let's move for further. Here, see, my dear students, see, testing a hypothesis on the single mean. Okay, metric data. If data is a normal distribution, then one sample test can use. One sample t-test can use. If data is non-metric, then chi-square we will use. This is about univariate technique. Your testing hypothesis about two related means. Two related mean independent samples. Independent sample mean for the metric, here is only one mean. One mean here is the, but same population, same variable, but two means. Okay, how? Independent sample test. For the metric data, independent sample t-test we can use. Okay, non-metric data, what we can use? Chi-square test we can use, or Whitney U-test use. Or related samples, paired sample t-test can use chi-square for the non-metric. Okay, the further one, the testing hypothesis about several means. I mean, several mean, metric means, numeric means, and more than two means, but same population. Okay. One-way analysis of variance for the metric data. For the non-metric data, chi-square we can use. Okay, now we are going to discuss the multivariate techniques. Multivariate techniques mean more than two variables can investigate, okay, in these techniques. If the data is a one metric dependent variable, analysis of variance and covariance, multi-regression analysis and co-joint analysis we can use. One non-metric dependent variable, I mean non-metric data, for what we can do? Discriminant analysis and the logistic regression. More than one metric dependent variable, multivariate analysis of, okay. So further slides, all slides are related with these slides. Okay, so now in further we can discuss these tests one by one, but I will not discuss the whole test in our lectures. In our course might be the some specific of test, some specific types. So in this respect, I'm going to discuss the first test. See here, independent sample t-test. I'm going to discuss first test, which is about independent sample t-test. Please, I need your attention. Okay, where is this one? Independent sample t-test. Let's see here, from here. Independent, see this one. See, this is also univariate analysis technique, independent sample test, but not single mean, two means. This is the two means, okay, here. And the metric data, I mean, the metric data mean, this is a normal distribution data. We can use independent sample t-test. If, so here. So discuss the above. So basic thing is independent sample t-test. Independent sample t-test is used when you would want to compare the means score between two different groups for one continuous variable. Variable is one. Okay, we'll give you the example. Okay, we'll give you the example which give you more understanding. Following a few appropriate situations where you could use independent sample t-test. Following, where is the following? These example, independent sample t-test, one variable but two means, I mean two groups. How? A teacher want to know if there are significant difference in the marks obtained in the subject business research method the student of two section. So what I'm going to check? Marks. This is the one variable, but the groups will be two section, one section and the two section. It means the two means will come, but all related with the marks obtained variable. Variable name is one variable. See here. See, check here. Compare the mean square between two different groups for one continuous variables. Two different group, but one variables. Here is no two different variable. No, one variable, but two different group related with one variable. Okay, another one. A manager would like to our manager would like to know if there are difference in morale for male and the female employees. Morale is one variable, but group is male and female. Got it? Okay, the marketer would like to know if buying behavior of the people of 2CT is same. Oh my God. Sorry for interruption. Let's discuss on the marketer or the company would like to know if buying behavior of people of 2CT is same or the different. So buying behavior is the variable, main variables, but 2CT are the group. CT1 and CT2 will be the group. Okay, another example is educationists want to investigate if teachers satisfaction varies between school and the college teachers, two groups. But what he want to investigate? Teacher satisfactions. Understand? Teacher satisfactions. Let's see. Each of above mentioned scenarios, we would easily see the data is collected on one continuous variables. Mark it. See, these are one variables. Marks obtained, morale, buying behavior, teacher satisfactions. However, it's collected from the two different groups. See, two sections, male and female, two cities, school and college. That are then compared using independent sample test. Okay. In this situation, we can use independent sample t-test. Paham? Understand? My dear students. Joseph from Sabah, Peter Gibson from Sabah, or Sarawak.
Sarawak, sir.
How about you, Joseph?
I'm Sarawak as well, sir.
Oh, you are also from Sarawak. Okay. Good. Oh my God. Assumptions. Can be the 15. Yes. Yeah. Okay. Assumption. So some of the assumption before proceeding a sample independent test. Okay. Assumption, your data must meet the following requirement. Data which you are collected, which are using to run a independent sample t-test. Okay. So dependent variable that is continuous, interval the ratio level. Yeah, because I know this is a parametric, should be a parametric. Then we can use interval the ratio. Independent variable that is categorical. Yeah, your independent variable must be a categorical. Yeah, now is a question for you, my dear student. Yeah, you ready? Be ready. What is the categorical or dichotomous data? I already told you what the meaning of dichotomous variable. Dichotomous scale. I already told you. How about the other your members? They left the group. Other two members, are they around? Don't be, take a stress. We all are friends to, have a session for the discussions. Don't be shy. This is my request to you, my dear students. Don't be shy. Dichotomous mean that only have two categories. Not more than two categories. Understand? I already told you when we discussed the type of scale, nominal, ordinal, ratio, we already, an interval, I already discussed. There was a one type of the scale, dichotomous scale. I mean that variable, that scale has only two categories, yes or no, male and female. Okay, see here. So second assumption is independent variable that is categorical, mean two groups only, not more than two groups. Good. And the third one is independent samples or the groups independence observations. Okay, suppose more discussion. There is no relationship between the subject in each sample. That means that subject in the first group cannot also be in the second group. Yeah. Okay. No subject in other group can influence subject in the other group. No group can influence the other group. Yeah. Everybody have a independent values. Should not see two groups. One group is Gibson, another group is a Joseph. So Joseph cannot influence to the Gibson and should not help to the Gibson, and Gibson also should not help to the Joseph. Anyway, violation of this assumption will yield an accurate p-value. Yeah, inaccurate will give you. If you violate these assumption, result will give you a type 1 or type 2 error. Understand? Type 1 and type 2 error. Okay, the main thing is normal distribution. Normal distribution mean in last test QQ plot and skew cortices. I already told you regarding normal distribution of the data. Your values should be acceptable according to the QQ plot and the skewness and the cortices according to. Okay, if that test is okay, your test is a normal, then you can run independent sample t-test. Let's discuss here. See, the normal distribution approximately of the dependent variable for the each group, non-normal population distribution, especially those that are thick-tailed or the heavily skewed, considerably reduce the power of t-test. Yeah, see, skewed, data is skewed, this test. If data is abnormal, will give you a, not correct result, not good result. Understand? Among moderate or the large sample violation of morality, yes, real PD accurate. Okay, the main thing is your data should be a normal. Now, we already discussed what is the independent t-test and the assumption for the t-test before run or adopt a independent t-test. We must know the assumptions. So, see, this one is the main thing. Reporting independent sample t-test. Reporting, this is the format. We can discuss one by one. First, we have to run the independent sample t-test for you people. We have to run the independent sample t-test for you people. Now is the time for the practical. Please be focused, my dear student. Okay, how we can run? So if for significant result, you can report like that. Independent sample t-test was conducted to compare, okay, add criterion variable, I mean variable name in the group 1, what is male, or maybe group 2 female, or maybe the college and the university. Okay, give the group's name only. Okay, there were non-significant. Okay, the difference T and this value can get from the SPSS group 2 and C. Okay, I'll give you. I'll show you. Wait for a while, my dear student. Okay, it's open. Okay, my dear students, are you around? So in respect of for insignificant independent sample t-test was conducted to compare, okay, this one also same give the data. Let's, how to run, how we can run this independent sample t-test on SPSS. Here is some of the, just go to the analyze and compare means, then select independent sample t-test. Okay, sample t-test in the second one, see, here is will come. You must give the here in the dependent variable here, dependent variable, then you can give the groups variable here, group is, see here, gender. I'm using the gender group. Further type is the group 1, maybe for the male, group 2 for the females, and continue, and then run. This kind of result will come. This kind of result will come. Okay, my dear student, this result will come. Let's this one interpret in the reporting how we can report. Here is the data. Okay, my hypothesis is there is a significant difference in the customer loyalty between a male and a female respondent. Customer loyalty, one of them, this is my variable, customer CL, because I use this data here. He used this data. See here. Independent sample t-test. Independent sample t-test, new data, missing value. Anyway, just report, then report. Number one, an independent sample t-test was conducted to complete the add the criterion variable. What is our variable? I think I just leave it as it, copy, duplicate slide. Then I can make changes. This one, the original one. This one, original one. Here I can make the changes. What is the variable name? Can you help me? What is the variable? This one is our variable, na? Customer loyalty. Customer loyalty. Okay, this is my variable. Customer loyalty. For the group one is male. Group 2 is female. According to this one, there is a significant difference in the loyalty between the male and the female customer. This is the H1 alternative hypothesis. Null hypothesis should be there is a no significant differences in the customer. Okay, might be. I can write here H note. H note. I can also write there is no significant differences in customer unity between male and female customer. Male and female customer or respondent? Respondents. I can track this one. So, now here we can decide which one is accepted and which one is rejected. I think null hypothesis should be okay. Also can go in this way. Okay, here. See, good. Okay. Now, an independent sample t-test. Yes, please focus. Huh? So, independent sample t-test was conducted to compare the customer loyalty for the male and the female. Okay, now this we already feel. There was a significant difference. T. What is the T and D? Let's see in here. Here, see. Which one is higher? This one, for your information, you must remember about this one because this is a group, two groups. This value is 0.13 should be higher than 0.05. 0.05 should be okay. Might be. I can show you here. Wait, here. Can I show you here? Show you here. See here. See here. This is one group, and this is the another group. So here the evaluate the assumption of the heterogeneity of variance p value p. It means this one significance mean p value should be larger than 0.05, and this one is larger, right? Larger than, and the other one, this one is the less than 0.05. To determine whether the test was significant, p value should be smaller than 0.5, but this one higher than. So which one is accepted? This one is accepted, right? This one is accepted. Let's see. Group number one is accepted now. Let's see in our result. What is the result here? See, check here. This one is okay. 0.31 is greater than 0.05, and here is 0.015 is less than. Okay, then what should we do here? Here, see, check the here, check here. Is better to run the later la. T is 0.72. T is 0.72. Let's check here. T is 0.72. Difference is here. Sorry. 2.47 here. Point. Yeah, this one. This one is 0.0014. 0.014. 0.14. I should drag here for your interpretations. It's very easy la. For interpretation, very easy. Just make interpretation quickly. Simple. Rather I'm reporting here. Just interpret. Just discuss this one. Just discuss this one. So this is the result. Now how we can interpret? Okay, we order independent sample teachers conducted CL4 in the customer loyalties for the male and female. There were significant difference. T higher one. Which T is higher? Can see here higher because T have a 2. We have a difference is 772. T difference, see here, 7 difference. Because this one is significant, na? 0.1. This is significant. And the difference is 0.772. 0.772. Can see here. T is difference because there was a significant difference. 772. And T value is 2.247. This one. See, 2.247, and the P value is, this is the P value, 0.014. 0.014. Okay, is the score with the mean score for the male. Now is the mean score for the male now. Mean, what is the mean and the standard deviation for the male? Let's check here. For the male, number 1 is the male now. See, when here 1. 3.92 is the mean. Standard deviation is 0.70. See here? Yeah, same. And was the higher lower than? And the female is the lower than, na? Okay, what is the female? We also can see. We can compare, na, which mean is higher. Main 1, I mean 1 is the male, 2 is the female. Male is higher. See, 3.9 is higher than female. Female is 3.8. Male is 3.9. You can report here mean. So you also can write these values. You can see also, you can write here. Okay, the magnitude of the differences in the mean differences. How many is the mean differences? 0.12. 0.12. Mean differences. This is the mean differences. How much is 0.12? Yeah, it's a difference between two. This two value is 0.12. You also can calculate on your calculator. And 95% confidence interval. Confidence interval, how we can measure? From here. This one is a confident interval, upper and the lower. See here, 0.025, 0.0, see 0.025 and 0.225. 0 point, see here, 0 point. This value you can say. Okay, see 90% confidence interval of the differences. You also have to report these values. You also have to report here. Now is your report is okay. So was significant. Hence H1 is supported. I mean, there is a significant difference in the customer loyalty and the between male and female because the result is significant, not insignificant. So you can see this is a significant. 0.014 is a significant. Okay, if insignificant, we can say this hypothesis is accepted. This hypothesis is accepted. No, result is significant. No, we accepted H1. If result is not significant, we will accept this one, H not. Understand? Got it or not? Because result is, because our hypothesis, there is a significant difference in the customer loyalty. Yeah, this result prove. Yeah, really a difference between male and female respondent. Now, I'm going to run our another fictitious data for you, fictitious data, or my paper data for you people to report here, In this another example, okay, another example will tell you for more clarity. For another example, let's see one another other example is satisfaction. They are going to check the satisfaction between satisfaction is the variable, gender 1 is male, gender 2 is the female. Okay, this is the mean difference, mean and the standard deviation between the male and female, and this is the value. Here is the insignificant. It means H null hypothesis will accept, right? Because this value is not insignificant, is more than 0.45, it should be less than 0.05. Let's see here how he interpret. See here the sample. So one another example is entrepreneurial intention is the variable, one variable divided in, going to check in the two groups, mean male and the female groups. These are the result here. Oh, still 0.034 is significant. It means the significance should accept the H1 hypothesis. See here, p value is first one, p value is this one. P value is should be greater than 0.c alpha is the greater than 0.5 alpha, equal variance assume. Okay, the compared p value comparison. See, this is the comparison here. And alpha less than 0.05. Okay, decided H1 is rejected because is x less than, if this value is suppose this value can be suppose 3, this is more than 0.5 now, then we can say decided H1 is accepted. H1 is accepted. Oh, sorry. Null hypothesis is H0 is accepted and H1 is rejected. We also can say H1 is rejected. Now, in this case, H null hypothesis accept or rejected because our result is significant. Yeah. So conclude, interpretation tension differs significantly between male and female students. Describe interpretation tension among female mean here is significantly higher than this one. Mean, you also can see mean is higher. Yeah, 2.9 is more than 2.3. Okay, so here you also can see H0 interpretation tension not differs between male and female student. H1 intention differed between male and female because this is accepted. So our result should be interpretation tension differs between male and female. Paham. You also can interpret, you also can read right here. This is another format as well. You also can APA style. Independent systems for the perform investigation, the mean difference of the interpretation. This is the limited information which we are giving, but you have to report in your thesis in this way. You have to report in your thesis in this way. I give two examples. This is the first example. Now I'm going to run on my sample. Let's run on my sample. First, I have to share with you people. SPSS. Where is the SPSS? Can you search? Yeah, SPSS. My dear student, can you see the SPSS platform? Are you around? Are you around and alive? It's too difficult. Today lecture is too difficult. Okay. So you can see. Okay. Anyway. Now I'm going to import the data. See here. Can go from here. Open data. Open the data. Wait. Here. Open data. You must know where is your data. I know where is it. D. Usually I'm teaching research methods. SPSS. Yeah. File. Give the file name. All files. Open. Okay. Hmm. Why not is coming? Okay. Running get data. Okay. We have to wait for a while, my dear student, for a while, because running to getting a data. Yeah, it's come now. Data is comes. Okay. So I'm going to calculate gender, this one, demographics. So male and female, I'm going to see the impact on my DV. My DV is fair. My DV is fair. You can see, wait. Fair, this is fair. I have to transfer first. Fair, I have to transfer first. Fair. COVID-19. Fair COVID-19. I have to transfer first. 1 plus 2 plus 3 plus 4 6 7 plus 8 divided by 8. Okay. Process is ready. Wait for a while, my dear students. Let's check the Fourier. View. Yeah, this one is ready. COVID-19. See. Now, let's go to run. Analyze. Compares mean. Sample t-test. This one or this one? Which one? Please tell me. Independent sample t-test. This one, my dear students. Now, which one is your DV? This is my DV. You also can check on different variables as well. No problem, any variables, but I'm going to check on the fair COVID-19 one. Now, see, here is my gender. Gender is here. Now, define the group. One is male. Two is female. Simple. Okay, then run. Wait for the result. Result is appears now. This is the result, my dear student. Now you can say, tell me the result now. Tell me the result now. See, which one is higher? More fair. Oh, it's my study is, yeah. Dear students, according to this one, females have more high, mean. It's more secure. My thesis is, let's check here for, oh, significant. Significant. My result is significant. H1 is accepted. H1 is accepted. See here. H1 is accepted. Now, how we can report in the, see, check. You also can import this result as a copy and paste there. You also can copy and paste there in the slides. Here. Sorry, yeah. Because I wrote now here. See here, table one. Table one, I couldn't show you. And must you give the table here? In this respect, maybe go here. Copy. Ooh, it's better. This one can represent in the Excel in very good form. Even the Word file might be here. We can use the picture. How we can take the picture? I know how to take the picture. We also can import from here, but if we cannot import, no problem. I'm going into using a picture. Simple. Oh, no, 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 no. No, 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 no. Sorry, la. I will teach you 4 tests. Today, I taught you, I'm delivering you a first test, which is about independent t-test. Okay. Copy and paste here for your understanding. For your understanding. Might be you can write there is a significant difference. See here. Might be I can, yeah, I can write here. Na? There is a significant difference. Difference in customer in fear of COVID-19. No need to give this one. Between male and female responded. Okay. So here is add the variable name here. What is the variable name? Can you tell me? COVID-19. Group 1 is male. Group 2 is female. T difference and t value. What is the t value here? You can see. Oh, negative 3.85 and the difference 7.3. Yeah, 3.732. But then you can report one by one. I already taught you because time is running only 2 minutes from our lectures. And give this is the result, by the way. This is the result. Okay, you can say we can accept H1. This is our result. H1. This is our result. Can accept. Not there is no significant difference. You cannot say H0 is rejected. H0 is rejected. The result you can give the here, and the mean here also can give the mean for the group 1 and the group 2. Group 1 and the group 2. Group 1 you also can give the result here. Group male. Mean, what is the mean? You can see here. Group 2 female. Female. You can see the result from here. See here. This is the male. You can see here. Might be female is mean is 26.237 and standard deviation. Okay. Maybe here you can write the female mean is more than here. Group number 2. Female must write here. Female mean was higher. Or might be also you want to use because it's lower. You also can see the lower than can go on this way also because it's lower. You also can use this one. See here because female. Okay, I have to. I must give the value as at least 23.22. 23.22. 23.22, suppose. Okay, 23.22. Standard deviation. Standard deviation 6.69. 6.69. Where is the 6.69 was lower than the female because female's mean is higher now. Oh, mean is 26.23. 26.23. Oh, I have to write 26.23. Standard deviation 6.58. 6.58. 6.58. Okay. The magnitude of the difference in the means. Okay. How much the difference in the mean? You can see the difference from here. Here. Here, mean difference. Yeah. Yeah, -1. Yeah, -3. 3.01. This is the difference. You can give the difference here. Here. And confidence value, the 0 upper limit. Yeah, it's not insignificant. Anyway, this is the basic test I already taught you. Now we can move for the attendance. That's all for the 2-day lecture. And there is any question, please use